Hello everyone, welcome back to lecture 7 of electrostatics. In this lecture, I will be teaching you electric field due to continuous charge distribution. But I will prefer before this, you just go and watch lecture number 6 in which I have taught you what is electric field. I gave proper feel of electric field and we have done some questions based on that. In that particular lecture, I have taught you what is electric field due to a point charge. If you will see that lecture, this will be easier for you. Okay. I just want to revise one thing from the previous lecture, that is due to a point charge at r distance, electric field is kq by r square, and from positive charge this electric field is away. From positive charge this electric field is away. If it's a negative charge, electric field will be towards. This is what we have done, and we have done multiple questions based on this. Is it electric field due to a point charge, which is kq by r square in magnitude and direction. From positive charge electric field is away, negative charge electric field is towards. Clear? I hope this part is clear. Okay. Now we are going to deal with electric field due to continuous charge distribution. By seeing the term continuous charge distribution, I hope most of you understood that here we have to play with integration. Okay. Now I want to make one thing very clear. Whenever you are integrating a scalar quantity, no problem. You can directly integrate without thinking. But whenever you are integrating vectors, they should be in same direction. You can integrate vectors directly when they are in same direction. If the vectors are not in same direction, then what you have to do? Then you have to take component of vectors. Take component of all the vector. Vertical, horizontal, vertical, horizontal. And then you integrate. Integrate all the vertical component because they are in same direction. Integrate all the horizontal component because they are in same direction. Get the vertical field whatever you got, get the horizontal field, and then you can do what? Vector summation of that. Whatever I told, just keep in mind. In question I will say you what I want to tell from this. Clear? So keep in mind, scalars can be integrated directly. Vectors, if they are in same direction, integrate. Without thinking, integrate. But if the vectors are in different direction, you need to take component. Horizontal, vertical. Integrate all the horizontal, integrate all the vertical. Then you can find the resultant. Don't worry, I will show you. Okay. So let's start electric field due to continuous charge distribution. Again, one more thing I want to tell you before this. What? That is different type of charge distribution. First is lambda, which is linear charge distribution. Linear charge distribution. Symbol is lambda. Whenever we have distribution of charge along the length, we call it linear charge distribution. I'm not saying 1D. You might be confused when the charge is distributed in one dimension. No, when the charge is distributed along the length. For example, charge on a rod. I have given total charge Q, length is L. So how this lambda is defined? Lambda is defined as charge per unit length. You all can write lambda is defined as charge per unit length. Clear? So this was a 1D body. Fine. Now, if I draw a semicircular ring, this is 2D. But how is the charge distribution? The charge distribution on this semicircular ring is one dimension. Not one dimension, basically along the length. The charge distribution is what? Along the length. This question might come. You can do mistake in this. That charge distribution on 1D body is known as linear charge distribution. No. Charge distribution along the length is known as linear charge density. Symbol is lambda, charge upon length. Here what you will get? Lambda is equal to charge. Let's say radius is r. So length will be semicircle, length will be pi r. Full circle 2 pi r, semicircle pi r. Clear? Second is sigma, surface charge density. Surface charge density, or you can also say areal charge density. When the charge is distributed across the area. Again you will think, sir, it means it's a 2D body. No, again I am saying it can be 3D body also. The charge distribution has to be along the area, across the area. For example, if I show you, let's say this is a square plate. If I give this charge, if I give charge on this plate, area is A. Now the charge is across the area. Total charge is Q. So sigma will be defined as charge per unit area. Lambda is charge per unit length, sigma is charge per unit area. I can show you a 3D body, let's say sphere having charge on the surface. A 3D body, sphere having charge distributed on its surface. So sphere is a 3D body, but as the charge is present only on the surface, what you will define for this? Surface charge density sigma, and that sigma will be, let's say total charge is Q, radius is R, so sigma will be charge upon surface area. The charge is on the surface area. Surface area of a sphere is 4 pi R square. So 3D body, but the charge distribution is what? Sigma. Clear? Third is volume charge density. I am rubbing this. Third is volume charge density rho. This is volume charge density. When the charge is distributed throughout the volume, again I have a sphere, but in this case the charge is present in the entire volume. Let's say total charge is Q, radius is R. So what is rho? Rho is defined as charge per unit volume. Rho is defined as charge per unit volume, which you can write here as, in this particular case, Q upon 4 by 3 pi R cube, volume of a sphere. Is it clear to everyone? Understood? Same, I can take a cube, I can fill the charge inside the cube, then rho will be what? Charge upon volume of a cube. So Q upon A cube, if A is the side. Clear? Or if you just pause and write, pause and write. So sigma can be defined for a 3D body when the charge is distributed on the surface. And for the same sphere, when the charge was in the bulk, we called it what? Charge upon volume, Q upon 4 by 3 pi R cube. You can pause and write. Clear? What is lambda sigma rho? Fine. Because we are going to deal with continuous charge distribution. So these things you should know. Fine? Okay. Now, just for your understanding, let's say this is a body on which charge is distributed uniformly, or non-uniform, doesn't matter. Okay, charge is there. From this body, total charge, let's say total charge is Q. Okay, from this body at a point P, I want to find out electric field. From this body at a point, at a distance here, at a point P, I want to find out electric field. Now, what you will say, sir, I know the formula for a point charge. For a point charge, the formula is kq by r square. But this is not a point charge. It's a continuous body having charge everywhere, having charge everywhere. So what we will do? Not only here, in every continuous body, what you will do, we know formula for point charge. You will find a point on the body. What you will find? A point on the body. This point will be very, very small. I will take a very small element on the body. That small element will behave like a point. So I have taken a very small element. A very small element will have what? Very small area dA. This very small element will have very small charge dq. Because of dq charge, I will find electric field. So it's a positive charge. So from positive charge, electric field is away. A small electric field D. What I did, I know the formula for point charge. So on the continuous body, I have taken a very small point, a very small element which has very small charge dq. This will behave like what? A point charge. A small element behave like what? A small element behave like what? Point charge. Because of this point charge, I will find electric field here. Then again, I will take one more small element here. A small element will have a small charge, and because of this element, I will find electric field dE. Again, I will take one more small element. Because of this small element, I will find electric field here. It means what I am going to do, I am going to break this body, continuous body, into infinite number of small elements. and because of all small elements I will find electric field here. Then I will apply principle of superposition. Clear? It means I will add all the electric field vectorially. Is it clear to everyone? Is it clear? Which is known as integration. Is it? Summation of infinite terms. We have to do what? Summation of infinite terms. Clear? How to integrate? What we have to do? You will learn. No need to worry. Understood? It was a continuous body. I have taken a small element. Because of that, I calculated electric field. One more element, electric field. One more element, electric field. One more element, electric field. One more element. In this way, I will find electric field because of all the element at this given point. Then we will apply maths, integration in a proper way to find out net electric field. Is it clear to everyone? Understood? Clear? What will be the value of this small electric field if I ask you? You will say, sir, K. This small electric field is due to this small charge. This small charge is dq. Divide by distance between the charge and the point. Let's say r, divide by r square. In the same way, I will find electric field because of all the elements. Then I will add them. Okay, clear? Pause and write. Just for your understanding. Okay, chalo. So we are going to start with our first element, which already I have done when I was teaching you Coulomb's law. There I have shown you force. Now electric field on the axis of a linear charged rod. Okay, so we are having a rod which is uniformly charged. I can make it non-uniform also. Don't worry, I will tell what to do in that. So this rod is having total charge Q. The total charge is Q, which is uniformly distributed. Length is L. At a distance on the axis of this rod, at a distance, I'm making a point O. At this point O, we have to find electric field. Now don't do one mistake. I have told before, center of charge. There is nothing like center of charge. Electric field varies as 1 by r square. It's not a linear variation. You all write on the top, there is nothing like center of charge. Keep in mind. Now, I need to find out electric field at O. Clear? I want you all to go through all the questions which I am doing today. After the class, do it by yourself once again. Because you know, these things can come in multiple chapters. In gravitation, in place of charge, I will bring mass. And I will ask you what? Gravitational field. Same we will do in magnetism. And center of mass. There also we need integrations. And not this, but I will take some hemisphere, solid sphere. So all those things requires what? Integration. So from here I want you all to build what? The fundamentals of integration. Clear? See how. At this point O, I want to find out electric field because of this rod. First thing is, this is a linear charge. So for linear charge here, what is defined? Lambda. What is lambda? Charge upon length. And it's a uniform distribution of charge. If you cut out 1 centimeter, both will have equal charge. Density is same. Clear? Now, what I will see here, okay, I want to find electric field at O. I know the formula of electric field due to a point charge, kq by r square, but this is not a point charge. It's a linear charge. So what I will do, I will, same thing, cut a very small element. From O, I will go to a random distance x. Whatever words I am using, I will use in all the integration in all the chapters while solving any problem. Go to a random distance x. Go to a random distance x. At random distance x, cut a very small element having thickness dx. This dx is very, very small, tending to 0. 0.000000001 centimeter, 1 meter, like that, 0.0001. Okay, this is very, very small element. So I went to x distance and took a very small element. This small element will behave like a point charge. And the small element will have very small charge, very, very small charge dq. Now you will say, sir, we know the formula of electric field because of a point charge. You made a point charge, yes or no? By taking a very small element, what I did, I made this point as a what? Point charge, very small element having what charge? dq. What is the distance of O? X. Don't worry about dx. Dx is very small. x plus dx is nearly x. No need to worry about that. Here we have the point O. So because of the small element, I know electric field. So what will be electric field? You will say, sir, it is a positive charge. From positive charge, electric field is away. So at the point O, this small element will give a small electric field dE. If I ask you what will be the value of dE, you will say, sir, K, a point charge dQ, is it? Divide by distance between the charge and the point, which is x square. Clear? So I got a very small electric field due to a point element. Now you will say, sir, let's see what other points are doing. What about this point? Small element, small charge. This is also giving electric field away. Positive charge give field away. Okay, so this element will also give electric field away. What about this element? This will also give away. What about this element? This will also give away. Okay, so we understood all the electric field are in same direction. When the vectors are in same direction, we can add them like a scalar. Yes or no? When they are in same direction. So here all the vectors are in same direction. It means we can directly integrate. Without any difficulty, we can directly what? Integrate, because all the field due to all the elements are in same direction. It means total field will be what? Total field will be dE plus D, dE1, dE2, dE3, dE4. Electric field because of all the elements will be in this direction, and I will add all the electric field, that will be the net field. dE1, dE2, dE3, dE4. I will add all of them, which is known as integration. Clear? So what will be the integration of dE? Integration of dE will be E, which is equal to K is a constant, it will come out of integration. Now one problem is there. If I am integrating with distance, operator should be dx. If variable is x, operator should be dx. But what we are having? dq. Okay, it means I need to eliminate dq and bring what? dx. For that, we will take help of what? Lambda. What is lambda? Charge upon length. Linear charge density. Lambda is charge upon length. Look at the element, the small element. This element has what length? dx. This element has what charge? dq. So lambda will be charge upon length, dq by dx. Therefore dq will be what? Lambda dx. dq will be lambda dx, which you can substitute here. So what you will get? K. Okay. Then in place of dq, what you will write? Lambda dx by x square. K constant, lambda constant, integrate. Clear? Just a second. Lambda, integrate. Okay. Now we have to put the limits of integration. So see, where will be the first element? From O, we are integrating what? Electric field due to element. Where will be the first element? From O, this will be the first element. At what distance? A. So lower limit will be A. And if I go at the last, if I reach here, all the elements are covered. This last element is at what distance from O? A plus L. So upper limit will be A plus L. Clear? Which is equal to K lambda. Integration of dx by x square. This is x power minus 2. So when we integrate x power minus 2 plus 1, divide by minus 2 plus 1. Is it? So this will be x power minus 2 plus 1. So x power minus 1, divide by minus 2 plus 1, minus 1. So minus 1 by x. And limits from a to a plus L. Is it? If I remove the minus, limits gets interchange. So k lambda, remove minus, limits will interchange. This will be a, this will be a plus L. Put the limits. So 1 by a minus 1 upon a plus L, which we can write as net field as k lambda. LCM will be a into a plus L, and you will get a plus L minus a. A cancel out. Electric field is equal to k. Put the value of lambda. What is lambda? What is lambda? Charge upon length. This is lambda. Charge upon length. Charge upon length into, here we have length upon a into a plus L. Length cancel out. Electric field is kq upon a into a plus L. This is the electric field on the axis, kq upon A into A plus L. For NEET kids, I want you all to remember one thing. You know electric field because of a point charge is KQ by R square. You remember like this, KQ by R square means R into R, distance into distance. First distance is A, total distance is A plus L. So distance into other distance, A into A plus L. Like this you can remember because this question can directly come in what? NEET examination. I hope you all understood. Clear? Now what maximum they can do in this? They can say that this lambda is variable. It means charge density is changing. They may say in this rod, the rod I have kept, on this rod, the charge is not uniformly distributed. They will say lambda is equal to lambda naught x, where lambda naught is a constant and x is what? This distance from origin. So as x will increase, lambda will increase. Means as you can just pause and write this part. It means when x will increase, charge density will increase. So here x is 0, no charge. As you will go right, x will be increasing, so charge density also increasing. Less charge, more. Here maximum charge you have, maximum charge at the edge. So nothing to do. Everything will be same. You will take same type of element. Just here you took lambda out of integration. See, focus here. You took lambda out of integration because lambda was constant, uniform. If lambda is variable, nothing to do. Just this lambda equal to lambda naught x you put here. Lambda equal to lambda naught x. So lambda naught will come out, but you will be having integration of x dx, which will be x square, x dx by x square. 1x cancel, it will be integration of dx by x, ln x. Clear? So if they change vary lambda, in place of lambda just put the function as the lambda is changing and then simply integrate. I hope it is clear to everyone. Great. Okay, you can just write if they change lambda, in place of this lambda we will put the function and then we will integrate. Maths will be same. Clear? I hope you understood. Good. Second is electric field due to semicircular ring. Okay, so now we have a semicircular ring. This is the ring having uniform distribution of charge and the total charge is Q and the radius is R. Okay, total charge is Q. So what will be lambda? I told you here also we have charge along the length. It's a 2D body but the charge along the length. So lambda will be charge upon length and length of semicircle will be pi r. Clear? Now we have to find out electric field at the center O. Electric field at O. We have to find out that. Clear? Let's find out what you will do. You can see one thing. I want to find electric field at O. In the previous case, what happened? In the previous case, this was point O and the charge was changing with distance. See, first element, second element, third element, fourth. Every element was at different distance from O. But in this case, every element is at R distance. See, if I draw a ring here, every element is at what? R distance. R distance, R distance. Distance is same for all the element. So what is changing here? Angle is changing. Here we have to play with angle. If you stand here, you have to rotate your head like this to see all the element. Is it? So here how we will find out electric field at O? How we will find out electric field at O? You will say. So do one thing. If the things are changing with angle, from here you go to a random angle theta. There I went to random distance x. Here you go to a random angle theta. Fine, I went to a random angle theta and you take a very small element, this very small arc, and this angle will be very small, which is d theta. So I went to a random angle theta and I cut an arc which makes what angle at the center? D theta. There I went to a random distance x and took an element dx. Clear? Now this is an arc, very small arc. The length of the arc is, let's say, dl. And as it's a very small element, it will have very small charge dq. Again same thing, I will find electric field due to a element, then I will go for integration. Now what electric field this element will give? You will say, sir, it's like a point charge, yes or no? It's like a point charge, dq. Distance is what? R. Positive charge, electric field will be away, dE. Value will be K. Charge is dq, point charge, by R square. Yes or no? So because of this small point charge, I will find electric field which will be away. Yes or no? Let's say dE. Which, and you will say, sir, dE, you can write the value K dq by R square. Understood? Okay. Now, if this is theta, vertically opposite, this is also what? Theta. Now, you know what is the problem here? The problem here is every element will give electric field in different direction. Every element will give electric field in different direction. Yes or no? If you look at this ring, if I take a point here, this positive charge will give field away, this positive charge away, this positive charge away, this positive charge away, this positive charge away. All the field are in different direction. We cannot integrate directly. Yes or no? Fine. So what we will do, we will take component of dE. For each element, I know electric field direction. I will take component of each electric field, one horizontally and one vertically. And I will add all the horizontal component and I will add all the vertical component. Yes or no? But you know, here one more very good thing is there. That is what? If you see about this line, the distribution is symmetrical. So whatever element we have here, here also we will have one element, mirror element. Here also we will have one element, and this element will also give electric field like this, which will be dE. This angle will be theta. Symmetrically, this angle will be theta. This angle also theta. Now this electric field, I will take component. What I will get? I will be getting dE cos theta. Yes or no? Let me highlight this. I will be getting dE cos theta. And for the same, I will be getting one down, dE sin theta. Same for this dE, dE, this is theta, dE cos theta, this side dE cos theta, and same, just a second, dE cos theta, and same, this will be dE sin theta, dE sin theta. Is it? You will say, sir, these two components are opposite, so these two components will get what? These two components will get cancel out. Horizontal component will get cancel out, vertical component will get added up. In the same way, this element and this element, electric field, horizontal cancel out, vertical add up. For every element on the right half, we will have an element on the left half, the mirror element, which will cancel its horizontal field, but their vertical field will add up. It means for every element here, we have an element here which will cancel its horizontal field and their vertical field will add up. It means for all the element, dE sin theta is getting add up for all the element which is vertically down. So for each element, you can write for each element, the vertical component gets add up. Which component? Vertical component. It means I can write net electric field will be integration of all the vertical component. For each element, the vertical component is dE sin theta. Is it clear to everyone? Now some of you will say, sir, I can see two element, 2 dE sin theta. You can take 2. But when you take 2, your integration will go only on the half, this half part from here to here, because you are taking 2 element at a time. If you take 2, then also same answer will come. Just be careful with your limits. If you take 2, it means you are taking 2 element at a time. Means you have taken this element, automatically this element is covered. This element, this 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 is covered. This element. So you will integrate only on the 1/4 part. But if you take dE sin theta, it means you are taking only one component of an element, so you have to go on the entire half cycle to get net electric field. So what will be net field? You will say, so net field will be integration of dE. What is dE? dE is the small electric field because of the small element, and that will be K. It's a point charge K dq by r square. I wrote there K dq by r square. So you will say net field will be integration of K dq by r square into sine theta. Oh, again a problem came. We are dealing with angle. Is it? We are integrating with angle. But the problem is with sine theta, I should have d theta. Operator should be d theta. But what we are having? dq. Okay, so again same thing we will do. You will say, sir, we know lambda. Lambda is charge upon length. Look at our element. Element has what charge? dq. Element has what length? dl. Yeah, but I want d theta. If you all remember, if I draw an arc, this angle is theta, radius is r, length of the arc is L. What is the length of arc? R into theta. So for our element, what will be the length? What will be the length of the arc? What is the radius? R. And what is the angle arc is making? D theta. Very small angle, d theta. So dl will be r d theta. Therefore, from here, dq will be lambda r d theta. This dq I can substitute here. All of you pause and write till here. Pause and write. Fine, great. I am rubbing this part. Now, net field will be, look there, integration of k sine theta. What is dq? dq just now we got lambda r d theta divide by r square. Fine. So from here, 1r cancel out. Net electric field will be k is a constant, lambda is a constant, radius. All element has what distance? Radius, which is constant. Integration of sine theta d theta. Now I am integrating with sine theta, with theta. So my limits will be in terms of theta. So from here I went to a random angle theta. If I want to cover all the elements, what I will do, if you look at this ring, from here I have taken a random angle theta. Yes or no? So where will be the first element? So this will be the first element, this one. So for this angle will be 0 degree. Yes or no? Then I have to reach to the other end. So first I am looking at the first element, angle will be 0. Then finally I have to look at the last element. Last element angle will be 180 degree. Last element from here angle will be 180 degree. Yes or no? So limits will go from where to where? First element 0 degree, last element 180 degree. Yes or no? So what you will get? K lambda by r. Integration of sine theta will be minus cos theta. From where to where? 0 to 180 degree. Put the upper limit. Or do one thing, if you remove minus, the limits get interchange. So upper limit will be cos 0 minus lower limit will be cos 180. Yes or no? Is it clear? So what you will get? K lambda by r. Cos 0 will be 1 minus cos 180 will be minus 1. This will be 2k lambda by r. This will be the electric field. And what will be direction of electric field? You can pause and write. You can see the cos horizontal component cancel out, vertical add up. So net field will be in what direction? Minus j direction. Is it clear to everyone? I hope you all understood. You can pause and write. Pause and write. You know, I have told vertical component get cancel out. If anyone have doubt in that, what you can do? If you see vertical component, what we got? dE cos theta. So to find out electric field, vertical component, electric field, vertical component, you can do integration of dE what? Cos theta. And when you integrate, you will get 0. Mathematically also we can prove. I hope it is clear to everyone. What I have done, listen, I went to a random angle theta. I took an element which is an arc. Angle is d theta. Because of the small element, I got electric field dE. Is it? Now every element was giving direction, electric field in different direction. So for this element, I got electric field like this. Symmetrically, I took one element here. This give electric field in this direction. So I got two electric fields like this. I took their component, their horizontal component cancel out, their vertical component add up. And vertical component was d sine theta. It means for every element, d cos theta is cancelled out by the symmetrical element, and d sine theta gets added up. So all d sine theta will be in what direction? Vertical, down. So all the components will be in same direction. Now I can do very easily integration. I integrated and I got that answer. Is it clear to everyone? You can pause and write. Pause and write fast. Okay. Next. One question I'm giving you homework. I want you all to try. And please write the answer in the comment section, whatever answer you got. So this is a quadrant. Total charge is Q, which is uniformly distributed, and the radius is R. I want you all to find out electric field at O. Clear? I will give you a hint. If you want, you can skip the hint. Go to a random angle theta again. Take a element. This will be d theta. A small element will have a small charge dq, a small length dl. Because of the small element, electric field will be like this, dE. All the elements will give electric field in different direction. This will give like this will like this will like this like this, like this. All will give field in different direction. So what you will do? Now, if the directions are different, we cannot integrate. So I will take component of all electric field. This is theta, this also theta. I will take component of all electric field. I will get component in this direction, dE cos theta, and I will get component in this direction, dE sin theta. Now any element you take, for all the element, one component sin theta will come down and dE cos theta will come left. So you will get filled in two directions. One will be the filled in y direction. That will be integration of dE sin theta. And one will be electric field in x direction, negative x. This is negative y. Integration of dE, x will be dE cos theta. And this, in this case, this electric field in x will not be 0 because there is no element to cancel out that. So you will get electric field in y, you will get electric field in x. You will get net field in y and net field in x. Now to find out the resultant field, you will take the resultant of both the fields. So resultant field will be under root of electric field in x, whatever you got is square, plus electric field in y, whatever you got is square. This will be net field. So whenever the field is in different direction, you take component horizontally, vertically. You add all the horizontal component with the integration, you add all the vertical component with the integration. So now you got filled in this direction because of all the element, you got filled in this direction because of all the element. So what will be net field? Net field will be vector sum of these two fields. Is it clear to everyone? Understood? Try this as a homework. Pause and write. Fine. Let's generalize this. Now R can come 60 degree, 90 degree, 180, 90, 180. I have shown you they can give 60 degree, 120 degree. So let's generalize this because this comes a lot. Especially for NEET kids, I am saying remember the result. For NEET and JEE Mains, I want you all to remember the result. Direct question can come from here. Now it's a arc having charge Q. Radius is R. And it subtends at an angle theta at the center. I want to find out electric field at O. Concept is same. I want you all to pause and try. Just find the magnitude. Direction you can find out, hai na? Positive charge, so away, field will be down. This much I think you can guess. So what I will do? So I will draw a line here. Okay. And what I will be doing, let's do one thing. Okay, fine. So let's make this angle beta. Okay. This total angle is beta. I will go from this vertical line. I will go to a random angle theta. From the vertical line, I will go to a random angle theta. See, whenever things will change angularly, this is what we will do. Taking element, you will learn by doing a lot of practice. So go to a random angle theta and make an arc, very small length, very small charge dq, which makes what angle? Very small angle d theta. Now because of very small element, it will behave like a point charge. So this will give electric field away, dE. Yes or no? If this is theta, this also theta. Again, I will take component of this. This will be dE cos theta. This will be dE sin theta. Yes or no? Symmetrically, if I say this is a mirror, these two are what? Mirror image. So symmetrically, like here, one element will be here, which will also give electric field in the same way. Yes or no? Again, whose horizontal, this will be vertical. Again, horizontal will get cancelled out because of symmetry. For this element is there. For this element is there. So symmetrically elements are there, which will cancel, like the previous case, which will cancel the horizontal component, and vertical component will get add up. So for each element on the right half, a element is there on the left half which is cancelling out its horizontal component. Like for this, vertical, horizontal, one element is here which will give vertical, horizontal, horizontal, vertical. Their vertical will get add up, horizontal will get cancelled out. It means for all the elements, only which component will add up? dE cos theta. So what will be net electric field? You will say, sir, for all the element, dE cos theta, dE cos theta, dE cos theta, dE cos theta is getting added up. So add all the dE cos theta component, which is known as integration. So net field will be what? Integration of dE cos theta. What is dE? dE is a small electric field. What is dE? A small electric field due to a point charge. Due to point charge, what is the formula of electric field? K. Charge is dq. Distance is, this is radius, na? For all the element, distance is same. R square into cos theta. Is it clear? Again, same problem. I am dealing with angle. So I should have d theta, but I am having dq. So what I will take? Again, I will take help of lambda. Lambda is charge upon length. The element has what charge? Element has charge dq. Element has length dl. It's a arc. What is arc length? Arc length is radius into the angle subtended. So radius is r, angle is d theta. So this length will be r d theta, r d theta. So dq will be what? Lambda r d theta. So in place of dq, I will put lambda r d theta. So integration of k lambda r d theta cos theta by r square. You can see r cancel out. So what I can do here is k is a constant, lambda is a constant, r is a constant, integration of cos theta d theta. Yes or no? Now if you see limits, now I have taken, this was the vertical, from vertical I have taken an element at an angle theta. Is it? This is what I have done. So I have to cover all the element. To cover all the element, what I will do? Look, this is the vertical line. So from the vertical line, if I go right, from here to here, so from here to here, so total angle is beta. So from here to here, this half angle will be beta by 2. And if I go back, this is clockwise, this is anti-clockwise. If I go back, this angle is also what? Beta by 2. So limits will be from where to where? Limits will be from this vertical, this is beta by 2 anti-clockwise, this is beta by 2 clockwise. So if I take clockwise positive, anti-clockwise will be negative. Be careful. So limits will go from minus beta by 2 to beta by 2. You want, you can do from here also. You can go from here at an angle theta, take a element, find electric field, then integrate from 0 to theta, beta. Integrate from 0 to beta. You can do like this also, like I have done for that semicircular ring. You can do, answer will come, same thing only, is it? So this will be k lambda by r. Integration of cos theta will be sin theta. Limits beta by 2 to minus beta by 2, which is equal to k lambda by r. Upper limit sin beta by 2 minus lower limit sin minus beta by 2. Sin of minus theta is minus sin theta. So k lambda by r sin beta by 2, and sin of minus beta by 2 is minus sin beta by 2. So minus and one more minus. Clear? You can write sin of minus theta is minus sin theta. So one minus will come out, minus minus will become what? Plus. So sin beta by 2 plus sin beta by 2, 2 sin beta by 2. 2 sin beta by 2. This is the formula of net electric field at this point O, which is 2k lambda by r sine beta by 2, where beta is the angle that the arc makes at the center. One more thing, you might be confused, sine beta by 2 or sine beta by 2. So sine beta by 2, clear? This is the electric field at the point O. And direction you can find by common sense, is it? You can just pause and write. How to find out direction? All are positive, net field will be down. Anyway, you are getting vertical component only, but you can use common sense, है ना? कि sir, all the charge is positive, they all will give resultant down. This is direction of electric field. Is it clear to everyone? You can pause and write. You can check also for the ring. If you look for the semicircular ring, what is the angle? 180 degree. Put 180, 180 by 2, 90. Sin 90 is 1. You get 2k lambda by r. If you check, same result came, 2k lambda by r. 2k lambda by r. Direction you can find with the help of common sense. Pause and write. Pause and write. Done. Clear. Fine. Next. Now third is very important. This third or fourth, whatever. This is electric field at a random point at a perpendicular distance d from a finite line charge. So we are having a finite line charge. The total charge, let's say, is q, length is L. This is not required, just lambda is required. Lambda is defined as charge upon length. So for this rod, lambda is given lambda coulomb per meter. What is the unit? Coulomb per meter. So lambda unit is coulomb per meter. What is sigma unit? Charge upon area, coulomb per meter square. What is rho unit? Charge upon volume. So coulomb per meter cube. Lambda coulomb per meter, sigma coulomb per meter square, rho coulomb per meter cube. Okay. From this finite line charge at a perpendicular distance d, at this point, let's say O, we have to find electric field at O. Clear? Pause and write this. I want to go to next page. Fine. So what we will do, this is a line charge having linear charge density lambda, charge per unit length lambda. From here at a distance, at d distance, I want to find out what? Electric field. Again, this is a continuous charge distribution. I know because of a point charge. So what I will do, I will go to a random distance y. and I will take a very small element of what thickness? A very small element of thickness dy. And this small element will have very small charge dq. And this I will connect from here. Clear? This angle is theta. You can do with theta also. You can say, sir, from here I will go to a random angle theta and I will take a very small element which makes what angle? D theta. Then also this length will come dy. Both you can do. From here you can go to a random angle theta. You can take a small element which makes what angle? D theta, and this element will have what length? dy. Whatever you want you can take, no problem. Or you can go to a random distance y and take an element dy. Now this element, very small element, will have very small charge dq, and this very small charge will behave like what? Point charge. Is it? And let's say this distance is r. This distance is r from the point charge to the point. So basically what we got? We got a point charge. This is our point charge. And from here r distance, we have the point O. So a positive point charge will give electric field away. This will give electric field away. Is it? Electric field away, which will be dE. Okay. And what will be the value of dE? You will say, sir, dE will be K. Charge is very small dQ. by distance between the point and charge is r square. You can just leave it like this part, okay? You can just write for your understanding ki sir has made a point charge, because we know the formula for a point charge. Fine, clear, understood, good. Now see what I will do. Because of the small element, I will draw electric field. I have shown you there, but here also I will draw. So from the positive charge, electric field will be away. And very small electric field, dE. Is it? Now, if this angle is theta, this also theta, vertically opposite angle. Now the problem is, every element will give electric field in different direction. I will draw here. Is it? See, multiple problems are there in this problem. Yes. What are the multiple problems? This element will give electric field in this direction. This element will give electric field in this direction. This will give in this direction. This will give in this direction. All the elements are giving electric field in different direction. Problem number 1. Second problem is, if you take this element, this is your y. Let me change the color. Not pink. This is your y. This is your r. Yes or no? And this is your theta. If you change the element, then what will happen? Okay, if I change the element, my y will change. Yes or no? My r will change. Yes or no? As well as my angle will change. Yes or no? It means we are having 3 variables. Clear? See, basically concept is same. Maths will increase, nothing else. Fine. So first thing is, all the electric field, because of all the elements are in different direction. All the electric field, because of all the elements are in different direction. Second problem is, we are having 3 variables. So what to do? Again same. First I will resolve the problem of different direction of electric field. So I will take component. For each element, I will take the component of the electric field. One will be horizontal, one will be vertical. Clear? So I will take component of this dE. So this side what I will get? dE cos theta. And here I will get dE sin theta. And I will call this component as the perpendicular component of electric field. We'll write later. So for each element, for all the electric field, I will do component horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical. And I will add all the horizontal component to get perpendicular electric field. This is known as perpendicular. If I will add all the horizontal component, I will get perpendicular electric field, and if I add all the vertical component, I will get vertical electric field. So here I will be giving you 2 formula. One for perpendicular electric field and one for parallel electric field. Clear? Understood? It means you can write here, we will take element of all the electric field. Clear? And then if I will add all the horizontal component, the net electric field horizontally, which I will name as perpendicular electric field, because this is perpendicular to line charge, is integration of dE cos theta. All the elements electric field I have broken into horizontal, vertical component. I will add all the horizontal component, integration of dE cos theta, and I will add all the vertical component, which will be net electric field vertically, which I will call as parallel electric field, is equal to integration of dE sin theta. Any problem till here? All of you just pause and check whatever I have wrote. Clear? So I'm going to do integration. You can draw this part at the corner to get the better feel. Pause and draw. Fine. And right there we are having 3 variables, and also all the field are in different direction. So this problem I resolved by taking component. Clear? Done? Good. Next, I am going to do integration. But before integration, let's find out the value of dE. I told you 3 variables. Let's see. So dE will be, if you see, what is dE? Electric field because of that element. So what will be that? K. What is charge there? dQ. divide by what is this distance? Small r, r square. Clear? Now the problem is I want to integrate with angle. You know, we have three variables, angle, r and y. Y can change. If I change the element, y will change. If I change the element, r will also change. I have shown you. As well as angle will also change on changing the element. Three variables we are having. Is it? So what I will do, I want to integrate with theta, because in the books and all, or the question which comes, the formula is in terms of theta. So what I will do, if you look here, look at the small element. Can I write for this element lambda is charge upon length? What is charge on the element? The charge on the element is dq. What is the length of the element? The length of the element is dy. Therefore, dq will be what? dq will be lambda dy. Clear? So in place of dq, what I can put? You will say, sir, you can write d is equal to k. dq is lambda dy by r square. I want to integrate with theta. So let's do one thing. Let's put this dE value. So what will be E perpendicular? E perpendicular will be integration of k dq by r square. I remove dq. In place of dq, what I wrote? Lambda dy. Very simple. That's what we are doing. So k lambda dy by r square. E perpendicular contains what? Cos theta. So I want to bring everything in terms of theta. If I have theta, my operator should be d theta. Integration d theta should be the operator. I want d theta, but I am having dy. Problem. And r is also a variable. I want to write r in terms of theta again. So what I will do for that, I want everyone to focus on this triangle. Focus on this triangle. If you look at this triangle, you will find out that what will be the value of tan theta in that triangle? You will say, sir, tan theta is perpendicular. This is theta, na? This is theta. You will say, sir, perpendicular y by base. What will be base? This is our base, d. Is it? So from here, y will be d tan theta. I want you all to differentiate this with respect to theta. So dy by d theta is equal to d constant. Differentiation of tan theta will be sec square theta. So from here I will get dy is equal to d sec square theta d theta. Hey, this d is the perpendicular distance. Perpendicular distance, keep in mind. Don't think it's differentiation. Okay. So in place of dy, I can write E perpendicular as k lambda. What is dy? dy is d sec square theta into cos. This is cos theta. So what is dy? d sec square theta d theta. d sec square theta d theta. This is our what? This is our dy. Divide by r. R is also a problem. So in the same triangle, again, if you observe, in the same triangle, you will get to know this is the solution of the first problem. Second problem, in the same triangle, what will be cos theta? You will say, sir, cos theta will be base by hypotenuse. What is base? D. What is hypotenuse? R. Is it? So R will be d by cos theta. So you can put r as d by cos theta. So you will write d by cos theta and square of that. So d square by cos square theta. Cos square theta will go on the top. So cos square theta, sec square theta will get cancelled out. So cos square theta, sec square theta gets cancelled out. And what we will be getting, you can just pause and write that part. Done. So what you will be getting, this was the second problem solution. So this will be k constant, lambda constant, 1d cancel. This d is the perpendicular distance by d integration of what is pending? Cos theta d theta. Cos theta d theta. Clear? Now I am doing integration with theta. So what will be my limits? Everyone pay attention. I want to find electric field because of all the element. And from here I have taken a random angle theta. See, from here I have taken a random angle theta. So from here, if I go like this, here, See, I have covered all the element. If I go like this, I have covered all the element. And same if I go below, I have covered all the element. Yes or no? So if I just in which color? Red. So from here, if I go and connect the top end, this angle theta 1 if I say, and same if I go bottom from here and this I write as theta 2, you can see that from here theta 1, from here theta 2, I have covered all the elements. From here if I go clockwise theta 1, all the elements are covered. See, all the elements. And below if I go theta 2, all the elements are covered. So my integration will go from where to where? You will say, so integration will go from baseline. If I take clockwise positive, so till theta 1, and below anti-clock means minus theta 2, like the previous case. So our limit will go from where to where? Limit will go from minus theta 2 to theta 1. So this will be k lambda by d. Integration of cos theta will be sine theta, upper limit theta 1. So sine theta 1 minus sine of minus theta 2. Clear? Clear? And just now I told you in the previous case that sine minus theta is what? Minus sine theta. So I can just write it as what? Plus sine theta 2. One more thing, keep in mind, very important, derivation if you forgot, for once it's fine, but you have to keep in mind d is the perpendicular distance. Very important, d is the perpendicular distance, and theta 1 is the angle taken from perpendicular clockwise. Theta 2 is the angle from perpendicular anti-clockwise. Yes or no? Look at the diagram. Because the way we are doing derivation, in the same way we have to put the variables from the perpendicular. One side you connect the end, theta 1 is the angle. Below if you connect the end, theta 2 is the angle. So that distance d, I should not take d, because differentiation d is also there. I should take some other a or r, but fine, no issue. You can remember that this d is what? Perpendicular distance. And from the perpendicular, one angle is clock, one is anti-clock. So in this also, one should be clock, one should be anti-clock. And I have put with sign and all, so don't put with sign, just put the values. Clear? Understood? Pause and write. Pause and write. I will zoom that. 1 second. Yeah. Pause and write. This part. Pause and write. Done. So right now we got which electric field? Perpendicular electric field. So perpendicular electric field is what? K lambda by d sine theta 1 plus sine theta 2. Now one is remaining. We have two electric fields here. Yes or no? We got perpendicular. Next is parallel. So let's do on the next page. What is E parallel? DE sine theta. See, DE you got, na? This is DE. This is DE. DE you got. Just put this value. Here we have cos theta. Here we have sine theta. And let's integrate. So this only will come again. Let me show you on the next page. So E parallel will be integration of dE. What we had? Integration of dE sine theta. Integration of dE sine theta. What was dE? dE was k, charge was dq, distance was r square, sine theta. Is it? So k, what was dq? dq was lambda dy by r square into sine theta. I am doing again for you. Okay, dq was lambda dy, yes or no? On this element, small element, length was dy, charge was dq, and lambda was given, is it? And then I told again we have to bring in terms of theta. So in that triangle, what I did, k lambda, in place of dy, what we got? You all can see d sec square theta d theta. We got d sec square theta d theta divided by r square. What is r square? If you check, d square by cos square theta, and limit went from minus theta 2 to theta 1. Sec square theta, okay, I missed sine theta. Sorry. Cos square theta cancel out, d cancel out, and E parallel will be k constant, lambda constant, d will come out, integration of sine theta d theta from minus theta 2 to theta 1, and this will be giving you k lambda by d. Integration of sine theta will be minus cos theta upper limit theta 1 minus cos lower limit minus theta 2. Is it correct? Upper limit, oh we have minus na, so 1 second. So this will be minus cos theta limit from minus theta 2 to theta 1. If I remove the minus, the limits will get interchanged. So minus theta 2 to theta 1. So the parallel electric field component you will get k lambda by d cos of minus theta 2 minus cos of theta 1. Is it clear? And cos of minus theta will be what? Cos theta. So you can just write this as cos theta 2. This is the electric field parallel to the finite line charge. Clear? Understood? Pause and write fast. Okay. So what we got, because of the line charge, this line charge with linear charge density lambda at a perpendicular distance d, I got electric field 2 component, one perpendicular, which came how much? Which came k lambda by d sine theta 1 plus sine theta 2. D is the perpendicular distance, theta 1 angle clockwise from the perpendicular, theta 2 angle anti-clockwise, and this is E parallel, which is k lambda by d cos theta 2 minus cos theta 1. Now you will say, sir, how you got to know this will be perpendicular, this will be parallel? It can be parallel above also. For this you apply common sense. What common sense? You know, basically here we have less charge, here we have more charge. If you look about this perpendicular, here we have more charge, here we have less charge. So basically what is happening, this is giving electric field in this direction, this more is giving electric field in this direction. Who is dominating? This is dominating because more charge is giving. Yes or no? So if this is dominating, so in these two who will win? This will win. So net field will be what? Somewhere here. So its component will be like what? This and this. So this is E perpendicular, this is E parallel. This is how you can judge. Let's say you forgot which was theta 2, which was theta 1. No need to worry. You write this theta 1, this theta 2. Just put a mod. Whatever answer you get, put a mod. And direction, decide like this. Which segment is more dominating? The segment which is more dominating, according to that segment, I will put my E parallel and E perpendicular. Direction of E parallel and E perpendicular. I hope you understood. Clear? Like if let's say this point I am finding, then what will happen? You will say, so this is less, this is more. So net field will be in this direction. So this will be E perpendicular, this will be E parallel. Is it clear? If someone asks what is the net field? What is the net field? You got E perpendicular, you got E parallel. So this will be your net field. And what will be the value of net field? You will say, so net field will be vector sum of both the field under root E parallel square plus E perpendicular square. Yes or no? I got two vectors, E parallel, E perpendicular. So to find out the net field, I will do the vector sum of both the field. Is it clear to everyone? Fine. Pause and write. We'll do some problems. Okay. So for today, some good problems are there. Don't worry, this is not the end. Next lecture, I will take some more elements, some good elements. I will take disk, half disk, hemisphere. For those, we will find out electric field. Very interesting. So let's do some problem. Lambda is given. This distance is A. This angle is 30 degree. This angle is 60 degree. Find E parallel and E perpendicular. Question number 1. Question number 2. Again, lambda is given. This distance is given as A. This angle is 30 degree. This angle is 20 degree. This point is O. Or don't take 20. This also you take as 30 degree. Find electric field at O. and this distance is A. All of you pause and try. Done? So first case, E parallel, or let's find out first E perpendicular, K lambda by perpendicular distance A, sine from the perpendicular, join the top end, one angle should be clock, okay, it's clock, plus other angle should be anti-clock, yes, it's anti-clock, that's all. E parallel, K lambda by A, cos theta 2, theta 2 means second angle first, so cos 60 minus cos first angle will be 30. Is it clear? Done. How to find out direction? No need to worry. Just keep in mind. And you know, if you forgot which one theta 2, theta 1, no worry. You write cos 30 minus cos 60. Direction you have to find out. Take the mod. Always take the mod. Direction how you will find out? You will say, sir, in this case, this region is more dominating. If this region is more dominating, this will give fill like this. So net fill will be in this direction. So you will get like this. This will be your E perpendicular, this will be your E parallel, this will be your E perpendicular, this will be your E parallel. No need to find, just you can just put a mod, this is the mod. Direction I will find with common sense. Okay, so no need to worry about angle and all. Clear? Come to this problem. You know, this type of derivations I will do in magnetism also. Even that part is a bit easier because there we have only one direction of magnetic field, not like E parallel, E perpendicular, not like two component. Okay, this question has came from magnetism a lot, but they have not given till now from electrostatics. They can give. See how, very important question. So you will say, sir, E parallel. Anyway, this is the charge. So you know the net field will be what? In this direction. So it will have two component, E perpendicular, E parallel. Direction I got. I need to just find the magnitude. What is E parallel? You will say, no, first let's find out perpendicular. K lambda by A or D, K lambda by D. D is the perpendicular distance. Is it the perpendicular distance? Is A the perpendicular distance? Yes or no? No. A is not the perpendicular distance. You need to take perpendicular distance. What will be perpendicular distance? This will be the perpendicular distance. Hannah, just extend it. This is perpendicular. So this is A. Angle is 30. A cos 30. So perpendicular is A cos 30. So perpendicular distance is A cos 30. Then sin theta 1 plus sin theta 2. From the perpendicular we take the first angle. So from the perpendicular you join the top end. So from the perpendicular first angle should be what? Clock. What is that angle? 60 degree. Yes or no? So first angle is clock. 60 degree, and we take the angle from the perpendicular. That's why I remember. I told you to remember. Derivation you forgot, fine. But keep in mind theta 1 clockwise from the perpendicular, theta 2 anti-clockwise from the perpendicular. And the distance we take, that D should be always the perpendicular distance, because the options will be confusing. They will keep the options confusing. Keep this in mind. Okay, they will not give you that directly you can get the answer. They will keep option in terms of A, in terms of D. In terms of angle, they will try to confuse you. Plus sin theta 2. Sin. Now theta 2 should be anti-clockwise. So from here, where you are finding the field, you join the lower end. So till now what was happening? This was upper end, theta 1. This was lower end, theta 2. Is it? One clock, one anti-clock. But here what is happening? If I go from the perpendicular anti-clock, this is the anti-clock. From here, this is the anti-clock. So if this is 30, this is 330 degree. So what you will write? Sin 330 degree. Yes or no? Instead of this, you know what you do? Whenever one angle is coming clock and other also comes clock. I think first of all what you thought, ki sir, in this case, one angle is clock, other is also clock. So whenever you get both clock, put a minus sign. Because sin 330 is what? You will say K lambda by A cos 30 sin 60 minus sin 30. This is the same thing which you will get. So either you take one angle clock and from here one angle to the other edge anti-clock, which is 330°. But to save your time, concept you understood, just keep in mind, if both are in the same sense, one you take positive, other you take negative, that's one you take positive, one you take negative, problem solved. Clear? In the same way, what will be E perpendicular? E perpendicular we got, na? What will be E parallel? You will say, sir, E parallel will be k lambda by perpendicular distance is a cos theta, and now we have cos theta 2. So cos, what is theta 2? What is the other angle? Other angle is 330. So cos 330, or you can take what? Cos 30. Is it? Minus cos, what is the first angle? First angle is 60. Is it clear to everyone? Understood? Fine. Okay, can we move to next part? Pause and write. Keep in mind, we have to take perpendicular distance. From the perpendicular distance, you join both the end. From the perpendicular distance, you join both the end, the top end. So one angle should be clock, the bottom end, the other angle should be anti-clock. But to save your time, as I told you, you go 330, you write sine 330, or you go in the same sense 30 and you write what? Minus sine 30, both will give the same value. So you should be good in trigonometry and these values as well. I hope you understood. Pause and write. If they ask net field, you can find the net field, not a problem. Is it? Now, electric field due to infinite line charge. Infinite. This I will do with the help of Gauss law also. You will learn Gauss law. But here also I want to show you. This is infinite. Infinite. See, practically, infinite does not mean that line charge will come from Venus and go till Mars. No. It's a relative term. Infinite, point. These are what? Relative term. For example, if I say, out of this which is point, you will say, sir, first one is point. But no. If someone is seen from far distance, all three are point. And if I bring an insect here, insect will say that, so this is very big disk. None of them are point. So point and infinite both are what? Relative term. If I say infinite line charge, you know what does that mean? That means you are very close to line charge. When you are very close and look up and down, it will be like what? Infinitely long. It will be like what? Infinitely long. Let's say this is 100 meter and you are 1 centimeter. So for 1 centimeter, I can say what? 100 meter is nearly what? Infinite. Yes or no? This is the meaning of infinite. So from this infinite line charge, at what distance? At d distance, we have to find out electric field. Clear? Same thing, E parallel, E perpendicular. What will be E parallel and what will be E perpendicular? So you will say, sir, K lambda, linear charge density is lambda by A. From the perpendicular, you have to join both the ends. Now this is going till infinity. So if you want to draw a line which meet this line at infinity, we know I have to make it parallel. Parallel lines meet at infinity. Basically, this is not actually infinity. You know basically what is happening. Let me explain you first mathematically. This is, let's say, 2 meter and your point is at, let's say, 0.2 centimeter. So which will be what? 0.002 meter. You will say, sir, join the upper end. This angle is theta 1. In this triangle, what is tan theta? Perpendicular by base. 2 meter by 0.002. So tan theta 1 will be what? This will be nearly what? So perpendicular, which is 1, na? Sorry. Perpendicular is 1 and base is what? 0.002. 2 into 10 power minus 3. This is 10 power 3 by 2, which is 500. So tan theta is 500. So theta is nearly what? 90 degree. Yes or no? If you are very close and you want to join the upper end, you have to go nearly what? Parallel. This angle will be nearly what? 90 degree. Yes or no? So to reach to infinity, this line has to go parallel. So this angle will be nearly 90, 89.9999999. And if here I want to go and meet, this will also go what? Nearly at 90 degree. So what you will write? So you can just pause this just for understanding. You can pause. Okay. So I got both of my angles. The angles are sine theta 1 sine 90 plus sine theta 2 sine 90, sine 90 sine 92, and I got k lambda by a 2k lambda by a. In fact, 80%, 85% question comes from here only. Okay. Second is E parallel. If you check, E parallel will come 0. Why 0? K lambda by a cos 90 minus cos 90 is 0, you will get 0. And it's obvious now. Why? Because about this line, upper half whatever charge we have, lower half we have the same charge. So this entire charge will give electric field in this direction. This entire charge will give in this direction. And as the charges are equal, so for this electric field I will have two component. For this field I will have two component. Their vertical will get cancelled out, horizontal will add up. That's why parallel is 0 and we have only perpendicular. I hope you all understood. You know, one more thing I can do here, I can ask you that again I have a line charge for which linear charge density is lambda, and this is semi-infinite wire. Find electric field at O. What is the meaning of semi-infinite? Here it's going till infinity. At this point you have to find electric field. Again you will say, sir, E parallel, perpendicular distance is D. E parallel, E perpendicular. So first you write k lambda by perpendicular distance is D. K lambda by perpendicular distance is D. So I told you from the perpendicular you have to join both the ends. So one end will go till infinity. So to go to infinity you have to go nearly parallel. So this angle will be 90 degree. And one end you will touch directly without rotating to any of the angle. So this angle will be 0 degree. So for semi-infinite, one angle is 0. So sine theta 1 is 0, sine 0 plus sine 90. One angle is 90. And here also cos theta 2. So cos 90 minus cos theta 1, cos 0. This is what you will get. I am saying again, if you forgot this theta 1, theta 2, no issue. You write cos 0 minus cos 90. Just get the magnitude. Direction we will find with common sense. So with common sense, direction will be entire charge is here. So field is away in this direction. So this will be E perpendicular. This will be E parallel direction. Is it clear to everyone? Understood? Fine. Let's do some more problems. Okay, the video is becoming a bit big. No issue. Infinity, infinity. Linear charge density, lambda, lambda. At this point, a distance from here, a distance from here. At this point O, find electric field. At O, find electric field. Linear charge density is same. Pause and try. Done. Okay, good. So I will find individually. First I will find because of this wire 1. Let's name this as wire 1. So if you look at the wire 1, this is the point, and if I join, perpendicular distance is A. If I join this and I join, this is infinity, na? This will go straight. So this angle will be, angle 1 will be 90, and as it is a square, it's a square, so this angle will be what? 45. Yes or no? So what I will get for the wire 1, I will get 2 electric field. How? And one more thing, here we have less charge, here we have more charge, so net field will be in this direction because of the first wire. Is it? Are you understanding? So first wire will give field in this direction. So for this, what will be the component? This will be perpendicular, this will be parallel. So this will be perpendicular, this will be parallel. What will be perpendicular? K lambda by perpendicular distance is A. First angle is 90, sine 90, is it? Minus plus sine, other angle is 45. Can I write the value? 1 plus 1 by root 2. So 1 plus 1 by root 2. In the same way, what will be E parallel? K lambda by A cos theta 2 means cos 45. So this will be cos 45, which is 1 by root 2, and cos 90 minus cos 90, which is 0. I got the electric field because of the first wire. Now I will check for the second wire. This is the second wire and this is the point. This is the perpendicular A. So I will join the ends. This will go 90 degree. And again you can see from here this is 45 degree. It's a square. Other is 90, is it? So this angle will be what? 45. 5 degree. I hope you can understand. Now in this case, one will go parallel. This is our line. This is our line charge. So in this case, what you will be getting at this point, which region is dominating? Here we have less charge, here we have more charge. This is more, so net field will be in this direction because this is more. So net field will be in this direction. It will again have one E perpendicular component, and this will be what? E parallel component. So let's write here. So for the second wire, what will be E parallel? In this direction. What is this E parallel? K lambda by perpendicular distance A, one angle clock, one angle anti-clock. So this will be what? This will be what? Cos. Just write the magnitude, na? I got the direction. Just write the magnitude. No issue. So one is cos 45, 1 by root 2, and cos 90 will be 0. And one will be E parallel. E parallel will be K lambda by A, which will be then sine 45 plus sine 90, which will be equal to what? Sine 45, 1 by root 2, sine 91. So 1 plus 1 by root 2. So these two directions, right and down, I got because of wire 1, and left and up, I got because of wire 2. So I got 4 vectors. How many vectors? 4. Let's plot them. So what I will be getting? This is right. How much? K lambda by A, 1 plus 1 by root 2. Then we have one down. How much? K lambda by A, 1 by root 2, means by root 2A. Is it? Here up how much? Open the bracket. K lambda by A plus K lambda by root 2. Open this bracket also. K lambda by A plus K lambda by root 2. And we have one left. What is that left? What is this left? This is K lambda by root 2A. So down is K lambda by root 2A, up is K lambda by root 2A plus K lambda by A. So you can see this and this will get cancelled out, and here this and this will get cancelled out. Here we have a I forgot to write A, sorry. Is it? So what I will get finally. So see, these two are cancelling out, opposite. This is pending, K lambda by A. These two are cancelling out, right and left. This is pending, K lambda by A. So net electric field will be what? Net electric field will be under root A square plus B square plus 2AB cos 90. Is it? Under root A square plus B square plus 2AB cos 90. Cos 90 is 0. So root 2 K lambda by A. This is what you will get. Under root A square plus B square. Both are equal, na? When two vectors are equal, result comes root 2 times when they are at 90 degree. And if two vectors are equal force, if someone will pull me, I will come exactly in between. That two are equal. So net electric field will be exactly in between, and value will be this. Pause and write. Understood? So what I have done? Nothing, right? Nothing. I just calculated electric field because of this parallel and perpendicular, because of this parallel and perpendicular. For this wire, this segment was dominating. So net field was in this direction. So component was right and down. And for this segment was dominating. So net field is in this direction, up and left. I have just plotted all the 4 together. That got cancelled out, and I was left with K lambda by A up, K lambda by A right. I just took the resultant. Is it clear to everyone? Is it clear? You can just pause and write. Fine. Next. Okay, I think you wrote. Clear. This part, let me zoom it. Clear? Fine. Okay. Next is, let's do one more problem. I have an infinite line charge. Let me connect with mechanics. Infinite line charge. At R1 distance, I release a charge Q1. Release Q1. At R1 distance, I release Q1. Find velocity of charge Q, let's say Q, when it is at distance, R2. See, this is positive charge, line charge, infinite line charge. So infinite line charge means what? There will be no parallel electric field. Parallel field will be 0. It will give only what? Perpendicular field. Is it? So this charge, positive line charge, it will repel, and this positive will move away. You have to find the velocity of this positive charge when it will be at what distance? R2 distance. Again, this question I can do in one line when I will teach you potential. But right now, let's say we don't know what is potential and all, how to solve. So you can see here we will get only which electric field? Perpendicular. How much? 2k lambda by d. If you check, turn your pages, check 2k lambda by d. D is the perpendicular distance. E parallel was 0. There was no E parallel. Now this electric field depends upon perpendicular distance. As the charge will go from here to here, the perpendicular distance will keep on changing. As the charge will go, perpendicular distance will keep on changing. If the perpendicular distance will keep on changing, it means electric field will keep on changing. And how much force electric field apply? If you all remember the second lecture, force because of electric field is QE. Charge multiplied by the field in which charge is present. Charge multiplied by the field in which charge is present. That is the force. Now if distance will change, perpendicular distance will change as the charge will move, electric field will change, which means force will change. So what I will do, again same, I understood I have to integrate because something is continuously changing. I will go to a random distance x. At random distance x, what will be the force? You will say, sir, force will be Q into E. What will be E there? E will be 2k lambda, random distance is x. What they are asking? Velocity. And they are giving us distance. I need to connect velocity and distance. I know force. From force, what I can calculate? From force, I can calculate acceleration. So we know force is mass into acceleration. Let's say mass is m. So force is mass into acceleration. So acceleration will be q 2k lambda by m into x. Okay, I got acceleration. I want velocity. Acceleration is dv by dt, but time is not given. Okay, what I can do, I have to relate with distance. So I know, if you all remember, I told in one of the lecture, acceleration is dv by dt. You multiply by dx and divide by dx. This dx by dt is what? Velocity. So acceleration is v, this is velocity, dv by dx. Okay, so I can relate velocity and dx, velocity and x. I can relate acceleration with v and x. So one is dv by dt. When time is given, I will use dv by dt. Here velocity and x relation they are asking. So I will write acceleration as what? V dv by dx. I will send dx there. So what we have? Q 2k lambda by mx, and this dx I will send there. Clear? Clear? Now integrate. How to integrate? Look at the limits. Charge is released at what distance? R1 distance. Yes or no? So when lower limit of velocity is 0 because charge is released. And here we are integrating with distance. So particle starts at what distance? R1. So lower limit is R1. Then finally, velocity is v. That's what we have to find out. And finally, distance will be what? From here distance, I have to find the velocity at R2 distance. So final distance will be R2. That's all. Now you can integrate. V dv will be v square by 2. Upper limit v, lower limit 0. So v square by 2 is equal to 2 constant, k constant, charge constant, mass constant. Dx by x integration will be ln x limit r1 to r2. So what you will get? So v square, I will send this 2 here, 4k lambda q by m. Upper limit ln r2 minus ln r1. We know ln a minus ln b is ln a upon b. So ln r2 minus ln r1 will be what? Ln r2 by r1. If I remove this square, this will come under root. This will be the velocity when the particle will be at r2 distance. I hope you understood. Just pause and write. So I think this is sufficient for this lecture. I will come with one more lecture in which I will take some more better problems, some advanced level problems, or beyond advanced we will do some questions in the next lecture. I hope you understood. For JEE kits, especially for advanced, it's very important to remember all derivation in whatever way I have done. For NEET kits, just feel the derivation and try to remember the result. Is it clear to everyone? Okay, so bye, take care.